G'day guys, this is just a very quick review of the Jinhang JDS2012A, a fancy little scope meter that I got. Now, this won't be the only review on this device, and this won't be the only review of this class of device, but suffice it to say I've actually been quite impressed with this product, so I'm looking at getting the higher end model. And so once that arrives, I'll have a bit of a shoot off between this and the new one, as well as with my regular bench scope, so I can really sort of show it off and see what the features are like. But without further ado, this is the unit. Comes with a decent assortment of parts, basic multimeter probes, a very basic scope probe, which is by no means spectacular, but also perfectly serviceable. It is one of the switchable 1x10x probes, which I'm personally not a huge fan of, but yeah, gets the job done. And of course it's just a standard BNC fitting, so I can use my other probes with it. Comes with a CD and USB cable. Of course I don't actually have an optical drive in my modern computer, so I haven't actually been able to test out the USB functionality on it, but it does supposedly have data logging and other such features. And so this is the unit. Pretty simple control panel. I've said for a long time that scopes without rotary encoders to actually explore the signal aren't scopes, they're toys. But I've actually found the interface on this thing quite usable, so whether I'm a bit of a hypocrite there, I don't know, but hey. So battery compartment, easily accessible. It runs on one single 18650 battery, but it holds a second, so as you can see labelled there, spare. So you can put two 18650s in it, and if you're out and about and it runs out of juice, you can just swap the battery over. Don't mind the 9800 milliamp hour battery, they're quite obviously fake. It's about 800 milliamp hour, so it's actually particularly bad for an 18650, but more than enough for a device like this, at least for short-term usage. So if we power it up, I'll try and get some better contrast there on the screen. And let's see if we can focus in on the screen any better. Kinda, sorta. And so starts off in the basic oscilloscope display. You can see it there picking up some trace noise. I don't have a proper signal generator to hand at the moment, so I can't give you a decent display of the oscilloscope, but if I just do your standard basic 50 Hz mains. So you can see there the update rate isn't huge, but it's viable. Try out the auto functionality. There we go, there's our mains. So now that's a quite clean, stable signal there. The controls initially sort of threw me off, but I've actually found them to be quite reasonable once you sort of understand how to work the thing. So if I just leave that there, we've got, by default, it's dealing with the vertical resolution, or volts per division, and you have a few other options. You press channel to get to the vertical options. You press trigger to obviously get to your trigger settings. Once you're there, you can then scroll. There's a tiny little red cursor there. It's a bit hard to see on the video, but it's not that bad in real life. So there you can set your trigger. You can pick rising and falling slope using the function keys. And trigger, you can have single shot, auto, whatever. Your standard run stop, so you can freeze a waveform to have a look at it. And then the horizontal button. Once you press that, you can then use the up and down arrows to adjust the horizontal timescale. There you go. The horizontal menu also contains your cursors, so you can choose to enable cursors. You can choose to change them from timing or voltage cursors, and you can see exact readouts of where your cursors are set to there. Similar deal on the channel mode. You can tell it what probe attenuation you're using, whether you want AC or DC coupling, and you can press the channel button again to see basic value readouts. So once again, they're not coming out too well on the screen there, but they do look quite good in real life. So just max, min, duty cycle, and peak to peak voltage. And that's basically it for the oscilloscope. You can use the left and right arrows to sort of pan around the signal. So in that case, I'm changing the vertical offset. If you go to horizontal, you can change the horizontal offset. I believe... interesting, I actually don't know how to center it again. But you do at least have along the top here your current offsets. So yeah, the buttons on the device I was actually quite impressed with. They are the sort of tactile membrane switches, but they are surprisingly clicky. They do give you a good sort of tactile feedback, so they're not too bad to use. Okay, so there we go, that's centered up. So that's the oscilloscope functionality, fairly basic. You also have amps, volts, ohms option. So you press that and you get into the meter. So now once again, the controls were not exactly intuitive, but fairly easy to use once you understand how to use them. You've got left and right arrows to move between the different modes. And you also have the 3 function keys along the bottom. These will jump you into different sections. So takes you to DC voltage, that takes you to resistance, and takes you to continuity test. And you can still scroll around from there. So fairly basic functionality there. We were talking a little bit in the electronics channel the other day about multimeters with them overshooting the original, like the signal as you apply the connection. Now, personally, I don't think this is a big issue at all. I've tested a really old meter that I have, and it didn't overshoot at all. It sort of, if I applied it to a 12 volt source, it counted up. First reading was about 8 volts, then 11 volts, then it stabilized at 12.7 or whatever. The Vichy VC97, which is the cheap multimeter I normally recommend, it has quite a bit of overshoot on the first sample that it gives you. When you first apply it to a 12 volt source, or roughly 12 volt, it gives you a reading up around 24 to 25 volts. The next reading after that is correct, and then it holds steady. So, seeing as multimeters aren't generally meant to be capturing impulse, like transient voltages, I don't think that's a big issue personally. But a few people have said they really don't like that because they get sort of freaked out. They'll apply the multimeter to something, it'll read a voltage that's twice what it should be reading. Their heart jumps for a second, then it settles down and they get a valid reading. This meter does do the same thing. So if you apply it to a 12 volt source, when you first apply it, it will read 25 volts or something like that, but then it will quickly drop down to the correct voltage. I can give you a quick demonstration of that. I have here just a sealed lead acid battery. It's charged to around 12.7, 12.8 volts. And so now multimeter probes. I will say quality wise, there was the one issue I've had with this device. That black probe is perfect, goes in fine. The red probe on the other hand, it looks like it's really misshapen here, but that's not really a big issue. It is soft rubber. But the probe itself, the actual banana connection, is misshapen as well. So when you plug it in, it doesn't want to go in. Now that is making good electrical contact there, but it's not fully in. I've tried with other probes. the probe itself, it's not the unit. So, seeing as you can get some decent probes now out of China for $2 or $3, I'm not really going to hold that against it, but do be aware the probes it comes with are utter garbage. So, if we give it a quick test here, 3, 2, 1, go. Okay, so you saw there it read slightly higher, like 300 millivolts, then it read over range, then it read 25 volts, and now it's settled down to the accurate reading of 12.79. So if I try that again, it is reading a little bit of floating voltage there, and then over limit, 22 volts, 12 volts. Now, again, personally, I don't think that's an issue. The accuracy of the meter does seem quite decent. It's as good as the VC97, which admittedly that's a $30 meter. This is a $110 US, maybe $150 Australian meter, but it does the job. Similar deal with resistance. You can see auto ranging there isn't super fast, but yeah. Connect it in, and yeah, that's not too bad at all. Most of that time waiting was for the auto ranging. And the actual resistance there, again, these are crappy probes. So that will go down to read 0.0 ohms, but it takes quite a while for it to actually reach that. Is it going to hit there? Yeah, there we go. So yeah, it's not very responsive on the resistance range, but it will give you a decent reading, and it just takes a couple of seconds before, if you want to measure down into the sub-ohm range, which personally I don't have much problem with. Open short continuity test. I've actually disabled the buzzer on it. I have to remember how I even did that. That's a very good question, actually. That was potentially back in the oscilloscope settings. That's another thing worth mentioning. On the oscilloscope side of things, you do have reference waves. You can store a reference, so that's nice to have. And yeah, there we go. So we got backlight level, language English, color scheme. The only other color scheme it comes with is white, black on white, which you can't even see on the camera there. There you go. So yeah, it'd be alright if you're in a bright environment and you have to have that sort of light screen, but I'm not a huge fan of it. Bring that down, and once again, so there you go. That's more what the display looks like in reality. Okay, so then sound. There we go. So yeah, now the buzzer on it was probably the saddest sounding buzzer I've heard in a very long time. I'll give you a good demo in a second. You also have auto shutdown and automatic dimming on the backlight, which I've turned completely off. So if we go back to the voltmeter, there you go. You may have heard that buzzer going off there. So it does eventually reach a rather standard multimeter tone, but there's this very definite sort of pew as it gets there. It sounds like it's crying. Again, not the best demo with these probes because they are sort of already tarnished and shit, but it is latching. It does miss strokes, but I think that's mostly these probes rather than the meter. But compared to the VC97, this actually has much nicer response on the continuity meter. But yeah, that buzzer sound is, I don't know, there's something wrong there. Okay, so then you've got, it will measure capacitance, which apparently it will go down to about 20 puff, which I thought was quite impressive. I'm not sure what it goes up to. I haven't really given it that much testing, but handy function for the meter to have. Your standard diode check, which is up to 4 volts, so that's quite nice. Grab an LED here. So this is the wrong way. Nothing. The right way. Is something wrong with this LED? There may be, you know. Let's find out, shall we? Nope, the LED works. So now I'm not sure, you can see the battery meter there. It is quite low on batteries, so I'm not sure if that's a problem. Possibly a problem with the probe there. Yeah, there you go, it's just auto shut off. So that's not a fault of the unit, that's a fault of the very crappy 60-cent 18650 I have in it, which has already seen a couple of hours use in this device, but since it was last charged. So that's not too bad. The diode mode, I'm not sure what's going on there. It could just be that the unit's low on voltage, so that's struggling, but it has worked correctly before, even with white LEDs. So yes, it is a 4 volt diode range, but I believe that 4 volts is probably sourced directly from the lithium battery via current limit or such. But yep. Now it does have a USB port on the side here. Bring this back up. It's mini USB, so in theory it can connect to a computer, can do data logging, and I believe you can even power the device from that USB port without having to worry about batteries or such in it. So if you're at a desk, you can just plug it into USB and run it from there. So this unit again is the fairly basic version. It was about $100, which compared to every other handheld / pocket oscilloscope, especially around that price range, it beats them hands down, mainly because it is a 200 million sample per second scope. 20 megahertz bandwidth, they do say 20 megahertz, but it will read up to 33 megahertz with some attenuation. But yeah, certainly compared to like the DSO Nano and that sort of jazz, this is a much better instrument. The fact that it's got the multimeter built in, honestly, the multimeter features aren't great, but they are good enough to use. So again, as an all-in-one tool, if you're only going to grab one tool when you leave in the shop, this is actually a very handy device. You can not only do all your standard multimeter checks, but you can switch over to oscilloscope and get a good view there. So, as I said, I am getting the JDS2012, which has a 2-channel 50 megahertz oscilloscope plus a 1-channel 20 megahertz signal generator, plus the multimeter side of things has more traditional banana jacks on the bottom, with a dedicated milliamp and 10 amp measurement range. This unit can do current measurements, but only in milliamp range. It is sort of just a digital connection there. So that'll do for this quick review. Hope you enjoyed, and I'll be back next time with the full comparison. Thanks a lot.